Hello everybody and welcome back. So in this next lesson we're going to be talking about HDAs and all of the Python scripts that work with HDAs. Now this is quite a lot. HDAs in my opinion are the sort of the absolute epitome of how Python can kind of work with Houdini. So there are so many ways that we can use Python to enhance the capabilities of what an HDA can actually do. And it's really like fully integrated into all the different aspects of the node itself, the definition, all the sort of scripts that are attached to that, and the parameters on that. So we're going to sort of work through it step by step because there's a lot of different contexts just within this one main context of HDAs where scripts can be applied, and all of them have their own slightly different kind of contexts or rules or their own Quarks dictionary. So we're going to sort of examine each in turn. So well, this will probably be a two-parter, but this first one I want to primarily just talk about the actual how we sort of work with HDAs and the actual Python modules that are attached to this. Then probably in the next lesson we're going to just talk about the actual callback scripts on parameters, all the different types of parameters that we have and how each of them can work with Python scripts as well. Okay, so I've got my test dummy asset over here that we created before. If you don't still have this, or if you didn't follow along previously, you can just create any HDA. Just publish a normal geometry node or a subnet, just so we have an actual HDA to work with. It doesn't really matter what's on it because we're going to just be adding some stuff to it. Now, when we publish an HDA, we have access to additional sections in here. So when we go to type properties, you'll see there are additional sections and tabs that we don't have when we look at just a geometry node and go to edit parameter interface. Okay, here, yes, we can change the parameters, but that is only one of the tabs in here. So our parameter tab is the same as our edit parameter interface, only this is working with the definition, not just the node instance. But there are additional sections, and these are the ones that we particularly are going to be looking at, especially this one, the scripts section. So that is why we need an HDA. It's not one of those things where you can kind of prepare it like you can with parameters. You could use the parameter interface, prepare an HDA, but just with spare parameters, and then convert it to a digital asset. Well, with HDAs, well, with the Python scripts at least, you definitely need to publish it first in order to start working with those scripts. Okay, so once you've got an HDA ready, then we're going to start working with this. So if we right click and go to type properties on here, you're going to see this scripts tab, and this is where we're going to place our scripts. Now these scripts are attached to the definition themselves. Okay, so they are embedded inside of the actual HDA definition on this node, right? Now in your actual .hda file, you can store multiple nodes. So you could have one HDA that contains multiple actual HDA nodes, which is where it gets a little bit confusing. That it's basically, it used to be called like a digital library sort of, or it's like a published library of assets. And I think that is a little bit outmoded, also just not a good idea. So whenever you're working with HDAs, I always advise that one HDA file contains one node. Okay, yes, you could have multiple versions if you do any versioning. So if we do the sort of namespace versioning, you would contain that within one HDA file, or you could separate those if you absolutely want to. But I would not recommend having one HDA file that contains, like a test dummy node and then another entirely different type of asset. Like I say, it is possible to store that all in one HDA, but you really should have one asset per library. Okay, because otherwise that HDA gets really heavy. It also becomes very difficult to then delete things from it. So this is just the easier way to work. Right. So these scripts are now going to be stored in the actual HDA file. Now, basically when we're going to go into more detail in the next lesson about actual callback scripts, but when we click parameters or click buttons or do anything with our node, including a bunch of event callbacks, like when we create the node or when we rename the node, when we change the input, all of these things are going to trigger scripts. And as I said, Python can sort of be present in all of these areas. So every time we click a parameter or change something on the node, we can run a separate Python script. But ideally, what we really want to do is have all of those scripts just be tiny little one-line scripts that just point right back to the root script. One main script that has every function and sort of callback event in that script, okay? Because you do not want to have to go and change at 50 different places if you maybe update the node or add something, maybe rename a certain parameter, and now you have to go and rename it everywhere, right? We want to have one central location, and then every other script is just a little sort of pointer function that just kind of says, hey, this event has happened, so go to the main script and run this function, or some, maybe it runs a function with certain arguments. That's fine, but either way, we're still pointing to one central repository. Okay, so let's talk about that, and we're going to create that right now. I just want to first point out there is a really useful help file in the browser. Okay. And if you go under the Python scripting section, and then there is a Python script locations page. I think I pointed this out in the early on in the course, but if not, then definitely check this page out. This is very valuable. It's got a lot of cool information, a lot of stuff that we've covered already. Here's your 1, 2, 3, and 456.py, and it talks about all sort of different contexts and ways that we can apply Python, right? Now, some of it can be confusing until you've actually done it, and so I think this course will help you understand this page a lot better. But then this is a really good way to kind of refer back to this, and it's got all the information included, right? And a lot of what we're going to be covering today is sort of mentioned in this. So if you need additional information, come back to this page and it will help you out, all right? So, here we're talking about our quags, dictionaries. It mentions multi-palm blocks and button and icon strips, and there's just loads of really good information in this page. Okay. So, and one of the things we're going to be talking about now is listed in here, which is basically all of the different event callbacks. Okay. So here are all the event type triggers. And that's what we're going to have in the script section, okay? So here is a list of our scripts, which at the moment we have nothing. And then on the right-hand side is our actual section where we write the script. Now at the bottom section here is where we would add a script. Now we can add a custom script, and we can point to an actual particular file and then load that in. But the easiest way is going to be to click this button, and instead of through a custom script, we're actually just going to use one of these defaults. And so the expressions one over here is specifically an H script expressions script. So we're not going to be using this one. But then all the rest of them are Python. Okay. And this one over here, Python module, is our main one, right? So you're almost always going to want to create a Python module script if you're going to be doing any callbacks, event callbacks, script like parameter callbacks, anything. You're going to want to create this Python module, and this will be the primary module that you have all your scripts running in, okay? Then the rest besides this one are sort of linked to a particular trigger. So the name actually tells you or implies what that trigger is, but we can also look at this help file, and it does give additional information about when that particular trigger takes place. But like I said before, what we're really going to do is just on that trigger, we're going to kind of just maybe grab a little bit of information and then pass it to the primary module. Now, the reason this one is specifically going to be our primary module is that this one has no sort of event trigger, but it also has special ways of referring to it. So there are some expressions that we can use to refer directly to all of the text that is inside of this main module. Okay, so you don't really want to even have multiple Python modules, even though I think you can create multiple, maybe, or maybe not. Let's try create another one. No. Okay, so it'll only let us create one, and that's good, because we should only have one, and all your scripts should point back to this. Okay, so let's go through the event callbacks quickly, just to kind of show you what some of the options are, and then we'll actually put one or two of them into practice. All right, so quickly we'll go through the list. The first one is before first create. So that will be when it actually, like if you're going to drop down a new node, before it even runs the on created node, it's going to run this before first create, but it also runs that when it loads the node for the first time, which includes when you load your scene. So if we had to put something in that script, then save our scene, close Houdini, then when we open up Houdini and load the scene, it will run that script. Okay, so you do need to be careful that that is desirable. Maybe you don't want something to trigger every time you load the scene, in which case then this is not the right module to use. All right, then we have onCreated, so that will trigger when we drop down a new instance of this node. OnLoaded will then be when that is loaded, which includes then when we actually open our scene, when we load the scene. Okay, so it's not when it's created, but actually when it is loaded with the scene. Okay, then there's also on updated. This will be if we go and change the definition, then as each instance that already exists updates itself from the new definition, it will run this script. Then there's on deleted, so that will be as we delete the node. Okay, but on deleted also runs when we exit our scene. So if we save and close, it's going to run the on deleted script. Okay, so that one's a little bit odd that it runs it when we close. So just be careful what we do put in there. Sometimes you think on deleted means, oh, the entire node is no longer going to exist, so I'm going to clean up certain things. You can use it to clean up certain, maybe like cached user data or something on the node, but you certainly don't want to do anything overly destructive, because if we save our scene and close, it's going to run that script as well. Okay, then after last delete, okay, so that's also going to run when we exit the scene, but it's also going to, let's say we grab a whole bunch of nodes and we delete them, it will delete them all, and then after all deleted, it will then run the script once. Okay, then so some of these I do use, but like I would say onCreated is probably the one that I would use the most often. A lot of these other ones are really used for maybe micromanaging things like versions or whatever. So if you have a very advanced pipeline, you may use this, but I haven't really found too much use for a lot of these, except the onCreated script is very, very useful, because a lot of the times you want to, when you're placing the node down, you want to do some things. Maybe there's another node that kind of goes along with it, or some kind of check that you want to do in your scene to try and assist the user in applying this node correctly. So you want to check maybe the bounds of all of the nodes in the scene in order to go and create other things, or there's lots of cool things you can do as you create the node. But now some of these at the end here are also very useful. For example, on input changed. This one is super good because, okay, at the moment our node doesn't actually have any inputs, but let's put the maximum inputs up to 4 or something like that. So if we apply here, you'll see there are now 4 inputs. So when we change our input, but that includes plugging things in, plugging things out, altering which like the order of the things that are plugged in, any of that will trigger the on input changed script. And what's also pretty cool is that that script has its own Quarks dictionary, which includes an entry in that dictionary, a key called, I think it's called input index. Yeah, here we are. So on input changed is Quark's input index tells you which index it was that was changed. So you might have a script then that says, okay, so when something gets plugged into the first index, it double checks that it is maybe a valid node, because remember your first input is going to be special. The first input is whatever's going to come out as well, but with changes. So you may want to be very careful about what gets plugged in, and if the user plugs in the wrong type, sometimes the whole node can crash. So you could build in a little check that has a switch and says if the user plugs in something of the wrong type, then you switch to just a null, and so that the whole scene doesn't crash and it's a lot safer. And then you'd maybe pop up with a complaint saying, hey, you've plugged the wrong thing in, do you mind giving the right type of thing? And you try and guide the user. But then you'd only run that on the first input, so when it does on input change, it first checks which input index was changed, and if it's anything other than the first one, then it just skips that script. Or there's lots of interesting things you can do just by knowing which input was altered. Okay. Then there is also on name changed. So that is literally on the instance of the node. If I go and rename my node to my node name and hit enter, as soon as I rename this node in any way, it runs the on name changed node script. Now that would be if we have some very specific reason to have maybe an explicit reference to the name of the node. So there's potentially on created. As the node gets created, we maybe add the node name to some kind of list somewhere of nodes to do something with. Like we could maybe have a render script that says, hey, when you go and render, all these nodes in this list need to first be added as a mat or something. Now, if we go and rename the node, and that is not an explicit kind of link, then we're going to need on name changed to go and update the list by removing the old name and adding the new name. Okay, and in order to help us with that, there is also a Quarks dictionary entry that says old name. So even though as we've changed the name, if we said my node like .name, it's going to return the new name, but we can also grab the old name because it is stored in a dictionary entry just within that module. So as the name gets changed, we can pass that information from this module into our Python module and run some sort of script. Okay. And then we have, so those two are very useful, by the way. I use those all the time. So very, very good, as well as the on created. And then on install or on uninstall. So that is when you literally actually so under assets, when you install an asset library, or you can remove an asset library so you can kind of manage it. Or here, if we go under asset manager, we can uninstall something, right? So we could delete this definition or just uninstall it. Then it's going to run the on uninstall. Again, I haven't up to this point really needed these. That is more for deeper pipeline stuff, because a lot of the time, if your pipeline is pretty basic, you won't really always be installing and uninstalling HDAs. You're normally just going to set up one location where you have all your HDAs, and then maybe one for that particular project. But it is possible, and at least it's good to know that these are here, so that if you need something to trigger whenever you install that HDA, you can put that in this script. Okay. So maybe there's some sort of other accompanying HDA that needs to also be loaded, or the user needs to define something maybe, So you could have a node that has, I don't know, some kind of pipeline reference. So it's maybe caching out to a very specific location. And so as you install the node, you need the user to say, hey, this is the location where I want you to kind of store all of my config scripts or something like that. And, your whole setup, your whole HDA will not work if it doesn't know that location. Then you could put that on install. And then when you uninstall, you then go and maybe clean up that folder. And then sync node version is actually just here for backwards compatibility. It's actually sort of an old script, so we don't really use this one anymore. I've personally never used it, but if you can read up in here, and it does kind of explain that it's sort of like it's kind of redundant, but it's there for old nodes that still use this. Okay. All right. So those are the kind of triggers, and so what's going to happen is that when that event happens, for example, something easy to understand like on created or on input changed, right? When that thing happens, then it runs that script, and that script could be doing basically anything, okay? And on that, like in that module, as it runs, it has its own Quarks dictionary as well. So let's do something like that. So we'll create an on input changed script over here. And let's just do something strange. Like let's just make sure that every time that we have a node plugged in, so I'm just going to put down a null or whatever. So then as we plug something in, we want to maybe go and set the color of the input node or something like that. Okay. So now we could build that whole script here in the on input changed section. But instead, I would rather go and put it on the Python module and have the on input change to just trigger the Python module. Okay, so let's first build the script in here. Now in the Python module section, we're going to, okay, I always import who, just it's such a habit, but just in case for some reason that module gets dropped. And then we're going to define a function here, right? Because we don't want this to run all the time. We don't want it to run every time we load the HDA. We just want to create a function in here, and then that function gets run when this event gets called. Okay, so let's just create something really, really simple. So we'll just call it, I mean, I often just call it the same as the trigger. So we'll just call it on input changed. Okay. For now, we won't give it any arguments, but what we can do is actually pass it the Quarks dictionary, because then we don't have to do anything in here except run it and pass it that dictionary, because that dictionary has some information that the Python module is not aware of. For example, that which input was actually changed. The Python module has no idea, but we can feed it that information, because that in here Quarks equals a dictionary that has that data, so we can pass it the Quarks. In fact, let's do that. Let's feed it the actual Quarks dictionary, so that in here we can do whatever we want with it. And let's just for the beginning, I'm just going to print something in here. So we'll just print input changed, okay, so that we can make sure that we have this working. Now this is something you should always be very careful. Look, maybe the more experienced you get with setting up scripts and stuff, then you can start getting a little bit smoother with your workflow, and you don't have to test every time. But because there's so many different contexts within Python in Houdini and the way that it all works, I don't think it's that bad to just, I always kind of check that something is working and triggering before I go and build a massive script into it. Okay. You just want to make sure that the actual callback works properly, or it works in the way that you intend it to, or that the Quarks dictionary has the data that you expect it to have before you start writing a giant script. And then, because the thing is, you go, based on this event, you call this, but this calls an external script, and then you pass it the data, and you write this whole thing which runs some other script. And then when you click run and it doesn't work, now you have to go and try and figure out where it all went wrong. It's like buying a new, TV or something. The first thing you're going to do is just, as you pull it out the box, is maybe just plug it into the socket and just check that it actually switches on before you go and run the cable through the wall and, drill them like holes to mount the TV on the wall, and you do all the work, and then you try and switch it on and realize that the TV's not working. Like, it's much better to just kind of do little checks along the way. So I always do this. I say just something simple, print input changed, and I just trigger it from here. And then I plug something in. And then when I get that trigger, I know that it's working, and now I can rely on that connection. Right. So on input changed, what we're going to do here is we need to run the Houdini module. Now, how do we access our Houdini module? Well, like I said, this module is special in that it has a specific function that calls it, okay? And that function is, now there's a few aliases for it, but the actual function is HDA module. And this is a function of the who.node class. So let's just go and find who.node. Right. And then if we go in here, HDA module. Okay. So it's important to note that this is on the who.node class, not the HDA definition. So you don't have to grab the node and then go node.type.definition.HDA module or something like that to get it, because it's not actually a function of the Houdini, like the HDA definition. It is a function of a node, and it goes in to find the HDA module. So obviously you could call this on nodes that do not have an HDA module, but if you do that, it will, I mean, I'm not actually sure. It will either error or it will just return none. You can always try it. In fact, if you ever wanting to build a proper script, you should actually always try this. So we can grab maybe something like here, geo. We pull in geo and we say dot HDA module and see what it returns. Okay, and it actually will return a module. That's interesting. Okay, so I guess it calls it for every node, but then on a geo node it will not have any actual scripts, unless, I guess, of course, Houdini has these scripts hidden and embedded on these nodes, because in here you'll see there is no HDA module. Okay, but obviously that one's calling it, so maybe it's invisible to us. But anyway, on our HDA we will be able to see that module, and so when we call HDA module, it's going to reference that module, right? And it references this module as though it is literally a module in here. You know, the same way that our who.node over here, this class, like everything under here has a whole bunch of functions, right? Well, and these functions are just defined. So when we define a function in here, then when we run our HDA module and then we go HDA module dot on input changed, it is referring to this function and it runs this function. Okay. Now, something I just want to point out, HDA module is the name of the function, but it does say you should also look at HM, which is just a shortcut for self.HDA module. Okay. And then it also references who.phm. Okay. And if we look at that, the phm is a shortcut for who.pwd.HDA module. Okay. So basically, remember that who.pwd is referring to ourself. It means print working directory. Okay, which basically says, you know, my current context, wherever I am, that's what I want you to return. So it's because we're on an HDA, it's going to return our self, okay, and then it's going to grab the HDA module from that, okay, because very often we want to grab the HDA module from our own node. Very rarely are we going to externally refer to this module. Okay, because that is a bit dangerous. We don't really know what functions are in a module that exists on another node. Normally, this script over here includes only the things that this node itself wants to run. So when you change a parameter and it runs a callback script, when we change its input or change its name, then it's going to do a bunch of things. But we don't want Geo1 to be able to go into this node and grab its own internal scripts and start running them. That is not really good. So that is why they've created these functions for us, which allow us to very easily reference the Houdini module on our own context. Okay, so in PWD, we can grab our HDA module. Okay, so that's how we're going to try and grab this, right? But I just want to point out that certain contexts allow the use of PWD and others do not, okay? And rather than having to try and like memorize which ones do, I always test it first, okay? So we're going to, on input changed, before we even reference this script, we're going to print who.pwd and just check that that works. Okay, because if pwd doesn't work, then phm is not going to work either, because it's just calling pwd.hda module. Okay, so with this script in here, let's click accept. Okay, now you have to accept before anything will take place, so you can't have that open and then fiddle with nodes here and wonder why it's not working. Okay, you can keep it open if you want and just click apply, but you have to either click apply or accept in order for that to change the definition first. Okay, so let's just say accept so you can see what's happening. And if we now go and break this connection or plug anything in or whatever, then it should trigger that script. So when we do that, you'll see what it prints is just a backslash. Okay, sorry, /. And that is not what we wanted. Okay, so these event callbacks are where this who.pwd does not work. Okay, who.pwd is intended for things like the your parameter callbacks. Okay, which we're going to get to in the next lesson. But what happens with these event callbacks is, even though they're attached to this node, they run in a sort of global environment. Okay. And in that global environment, it's literally just its location. So its who.pwd is just slash. The same way you'd have /obj/, right? Well, this is the absolute top root level global environment is where that script is running. So who.pwd is not going to help us in this case. So what do? Well, we can say who.node, node, and then we just refer to ourself. Okay, so let's see if that works. Right, so let's plug something in. That still doesn't work. Okay, so there's one final. Now I'm showing you all of these methods because some of them work in some contexts and others do not. Okay, so you should always test the context, because I mean, I haven't tested each and every single one of these, but you might find that some of these event callbacks work differently to others even. So you know, it's worth always testing at least on one of them first. So another thing we can do is refer to the node, our current node, by using the Quargs dictionary. So let's print the Quargs dictionary that is taking place in here. Okay. Now let me just clarify in case anybody is still confused about this Quargs. When this script is called, it is passed a bunch of information. And that information has sort of keys and values. So instead of just being loose information, so a bunch of numbers, you know, for example, let's say I just said to you, I just gave you a list of the numbers, you know, 1.8, 30, and, you know, 16 or whatever. Now, that means nothing. That literally means nothing to you, unless I tell you what each number means. So that's the point of having a dictionary instead of a list, is that dictionaries come with additional information about what each value represents. So when I say 1.8, it makes much more sense if I say height 1.8. Okay, so now we know that this object or person or thing or whatever is 1.8 meters tall. Okay, what if under here I now said age 30? Okay, and then over here, you know, maybe day of birth. Okay, now this all sort of starts making sense, and you can see you know, actual information about this person, right? So, and this is, because it's a dictionary, these are a bunch of keyword arguments, and that's what Quargs means, is keyword arguments. So it's going to give us a bunch of information in a dictionary where it gives us the value, but it also tells us what that value kind of is. It has a label to it. And although there is some overlap between these Quarks dictionaries with certain events or even parameters, like for example the node that we're running this on will be the same when we have an event callback as it would on a parameter callback, because they're both taking place on the same node. But the value or something like that will be different, and then there are some keys that only exist in this one module and do not exist in the parameter callback over here. And for example, our where was it over here? Our input index will only exist on our onInput change. If we run a parameter callback, then it doesn't have any meaning behind saying which input was changed. It's a parameter. It's like a button. You click the button, you don't need to know which input was changed because no input was changed. Okay, so that's what this Quarks dictionary is, and it is just a dictionary that is stored in a variable called Quarks. So it's like somebody said Quarks equals and then defined a dictionary and then gave it a key and gave it a value. Okay, now Quarks is just the variable name that they chose, because that is actually what it is. It is a list of keyword arguments. Okay, so we're going to print Quarks and we're going to see what information we have available to us in here. So when I say accept, now when I change input, and I just want to show you, we don't have to keep even unplugging and deleting it. We can even just plug something else in, right? Now here it prints a dictionary of information. Okay, so we have one key, which is node, and it has a node reference to our node obj my node name. Okay, and then we have type, which has a who.node type object for test dummy, so it knows what type this node is regardless of the name. And then it also has input index, which remember I said this is a key that will only be triggered on this event, and that is 2. And the reason it says 2 is because this is 0, 1, 2, 3, and I plugged 2 in. If I plugged 2 out again, then input index would also be 2. But let's say I unplugged the first one. Well, now it would say input index 0 instead of 2. Okay, so you see what's happening here. Now if we go and do something else, for example, let's go create a on name changed, right? And then when we print Quarks, so we have the exact same script in this module and this module, but when we change the name to something else, it prints a different Quarks dictionary. Now, node is still the same, type is still the same, but now it does not have an input index key, but it does have an old name key. And so the old name used to be my node name, but now this is the new name. Okay, and if I wanted to compare the old name and the new name, I could just take this node reference and run .name, and now I've got the new name, and then I have the old name over here. Okay, so you see how the Quarks dictionary is different depending on the context. So on input changed, we have this Quarks dictionary, and in order to grab the reference to the node that we're on, because this is running in a global environment, we cannot use who.pwd, or we cannot even use who.node and then just dot, which means myself. So we can use our Quarks node. Now, because this is a dictionary, we just refer to it using square brackets, and then we feed it the key, and it will give us the value. So if we feed it the key node, then it will give us the value, which is you'll see with the triangular braces. So this is an actual Python object, which is a reference to our node. Okay, it's the same as us pulling this node in and saying, just printing that. Okay, so this who.node and the path to the node will return the exact same object. Okay, so we say Quarks node. Okay, so that is our self. In fact, I'm even going to store that in a variable called self, just for clarity's sake. Okay, so now when I say print self, then let's say accept. So now if I plug something in, it's going to print. Now it prints the word something else, which is the string for this, but that's just the way that nodes are represented. Okay, if I wanted to, I could say on here print self dot type. Okay, and then when we plug something out or in, it's going to print the node type. Okay, so because we now have a reference to the node, we can reference the Houdini module. And how do we do that? Well, we can either use the long form, which is HDA module, like that, or we can just use the short form. It's just an alias for this, the short form, which is HM. Okay, so self.hm just grabs the Houdini module. Okay, so I know it's called Python module here, but it is the HM is basically the Houdini module, right, on here. So now it refers to this module, but we need to actually call any functions within this. Okay, because this is an entire module of our own, if we defined a property in here, so we said something like foo equals 1. Okay, so now when we say print self.hm, if we just did that, it would just print a reference to the Houdini module on that object. Okay, if we said print self.hm.foo, right, then when we plug this in, it's going to return just the value of foo, because foo is being defined here. So we can grab properties that way. And now remember, with a property, you do not call it. It is not callable. It is not a function. It is just a value. So we can grab it that way. But if we want to grab an actual value over here, then, a function, then we have to call it. Okay, now you do need to be careful in this to not have, you want a bunch of functions, you do not want loose just sort of scripts running in here. For example, if we print something like hello, right, then because this is going to call that module, right, when we break this, okay, oh wait, it's not gonna, all right, it's not gonna print, so that's at least fine, right. Phew, at least we don't have to worry about that. But we want to call this, so we use round brackets, and then we have to feed it the arguments. So this is the same as running, this is a user-defined function, but it's the exact same as running functions in here. Okay, so under our here, this where we've given a list of arguments, well, that's exactly, we're just defining our own function. Okay, so under here, we then say dot, I think we called it on input changed. Yes, okay. And if we give it no arguments, then it will complain, because it actually needs us to feed it an argument. So, but what we can do is just feed it our quags dictionary, because that's actually what we're expecting it to feed us. Right? Now we're not doing anything with it in here, but we are feeding it, and that will then satisfy this this function. Okay. So now if we say accept and we change this, it's going to print input changed. Okay. And now the reason it printed none over here is because actually we're not just running this, we're actually printing it, and it's returning nothing. Because inside of here we don't have return and then some sort of value. So it's just returning nothing, and so it's printing none. So we wouldn't print it, we would just run it like this. Okay. So now when we do this, it's only going to print the words input changed, because that's what's happening in our function. Okay, so I hope that all makes sense now. You can see how we can call this a function, user-defined function from our Python module. We can call it from here. Now this is really all that these functions should look like, is a couple of lines to sort of just grab a reference to self and then call a specific function, right? You could potentially do something like, say, if, you could do a quick check and say, well, if the input was plugged in, then do this function, otherwise do that. But even that I prefer to do in my Python module. So I would rather just have these two lines. Call the onInputChanged function in the Python module, feed it the entire quags dictionary, and then have all of the work done in here, including checking the value, and then if if the input was plugged in, it has to run a separate function to if it was plugged out. Well, then have those two functions in here, either globally inside the module, or a sub function. So you'd say define plug in, and then you'd define another one called plug out, and those would be your two options, and you'd run either one of these two functions depending on what was changed. But you can do the if statement and have the sub functions, or these could be global functions out here that you would then call, whichever way you want to go with it. But the best practice is to do all of your work inside of here, and this module does nothing but call this function, but feed it all of the data that it had when running. Okay. In fact, technically, by the way, you don't have to do this self and then self. If you really wanted to, you could just run. You could say quags node, which is going to return a reference to the node .hm.onInputChanged and feed it the quags dictionary. Okay. And you would do almost the exact same thing for every other event callback that is relevant. You don't need to go through and do it to every single event callback if you're not planning on using them. But if you are planning on doing some sort of on name changed, then you just call the node from quags, call the HM, and run on name changed and feed it the quags dictionary from this. The only thing is now in here you'd have to have a function for each and every one of those. Okay, so define on name changed and grab the quags dictionary from that. Okay, so if we print the quags from that, and now we print the quags here, these two are doing the exact same thing, but actually the two dictionaries will be different. So as I unplug that, it gives us our input changed dictionary, and if I rename this, then it's going to return the on name changed quags dictionary. Okay, so that about does it for the kind of the Python module and the event callbacks. Now, there are many more ways to refer to our Python module, and we will be doing so through the parameters and menus and all sorts of other things. But for now, this was just sort of an intro so you can get used to the Python module and then these events. And then in the next lesson, we're going to go through all the other ways of writing scripts in here and then referring to them on our HDA. Okay, but it's just important for you to understand that this module is where essentially everything is going to live. All of our scripts live here. Now, I just want to sort of to explain the target or the best way to work. Now, I fully believe there are some situations where it's much smaller. Okay, if you're going to create a quick little HDA that does one small little thing, you don't need to go and create an entire external script that you then reference. You can just drop down your Python module and run a script in here. Now, even on a small level like this, let's say we just wanted to recolor our node based on when something's plugged in or not. Okay, then we could do that just in here. We don't have to offload that to an external script, but I would still not do any actual scripting inside of the on input changed or on name changed. So these, please do yourselves a favor and only trigger an actual script on the Python module. Even if on the Python module this script is really, really simple, just keep it here. It's much neater to have those all just pointing to this. It's kind of like a remote control. The little button on your remote, that's not doing anything fancy. All it's doing is sending a signal. This is a signal, this is a signal, and it's going to the actual kind of central processing unit that is saying, okay, that button was pressed, now let me do some stuff. This is I would say the minimum that you should do, even if it's really simple. Now, the next step beyond this, which is something we're going to be using when we move forward into the next module where we build our actual pipeline tools, is that even this would just be triggering a script with an almost matching kind of name and data that is external. So I know it's a little bit odd that this event callback just sends a signal to the Python module, and the Python module will send a signal to our external script. But it's because what we're trying to do is keep this as minimal as possible, and in fact to have nothing here that needs changing, so that we can have all of the data manipulated and altered in our external script. Now, that is not always the best thing to do. Sometimes it is good to have your scripts embedded, and other times you want them offloaded to an external script. There are pros and cons to both. And I think it's important to sort of discuss this for a minute so that you understand. Okay. If we have a script embedded here, then it is saved in my HDA, which means if I want to change it, I have to open this HDA. So actually go to Type Properties, come in here, alter the script, and click Accept. Now, what does that do? If we have, especially in a bigger, like a studio or something, you might have this node is something that's already being used. Maybe it's a digital asset that does something really useful. So it's in a wide variety of scenes. And those scenes are busy on the render farm right now. And now you go and make a fundamental change to the script. It's going to break everything that's on the render farm. I mean, maybe you'll be lucky and change it in a way that doesn't break it, but odds are you're going to change something fundamental and it will break. Okay, so there is no sort of easy way to do that without just going and making sure that everywhere where this node is used is paused on the render farm. Then you would go and change the script. So that can get really messy in a kind of a studio context, which is why 9 times out of 10 it is better to offload it. Because if this was just pointing to an external script, if I now go and, without having to go and alter all the HDAs, I can just go to my external script and make a change, okay? But then again, I have to be really careful, because if stuff's on the render farm and I make a change to my external script, it's going to break everything that's on the farm, right? So in HDAs, you can version. So we could have test dummy version 1 and then test dummy version 2, and each one of those would have its own script. Okay, that can become a pain to manage, because version 1, go to version 2 and make a change. Maybe you do a bug fix. But if it's a bug fix, technically you really want all versions, including you kind of want to be backwards compatible, because maybe one of your older scenes is still using the old way that the script used to work. So you're using version 1 still, even though you've moved on to version 2. You do a bug fix in version 2, you kind of need to also support that bug fix in version 1. So there's a lot more admin that goes into managing versions, but then it's not going to break your stuff on the render farm. So like I say, there are pros and cons, and some people just have a preference. They just prefer working one way or the other. But I think it's worth examining what you're trying to do with the node and who's going to be using it. Is it just you? Is it just a node that is used to create a cache, and then that cache gets rendered separately on the render farm, so your node never ends up on in a scene that ends up on the render farm? Then that's a different question to whether it's something that actually gets rendered, and whether you need access to be able to update and change it without having to go to every single HDA and update the script inside of it. Okay, so it's worth considering, is all I'm saying. Now, most cases, in my experience, even though there are drawbacks to working with external scripts, I've found that most studios work that way. Okay, you have to be careful, like I say, otherwise you're going to break things that are currently rendering. But that is always a kind of an occupational hazard of doing any kind of coding, is you need to be very careful, because if people are relying on the script, it's like building a bridge, people are relying on the bridge working. You can't now start working on the bridge while there's still people on it, because then the whole thing might collapse, and then, that's a disaster. So you need to be careful, but most of the time, in my experience, you will use external scripts wherever possible. And so this is just step 1 of learning to kind of have one event trigger another function, but really this is only one step in the chain. We're going to be taking it one step further later on, where onInputChanged just runs another script and passes the quarks to that, and that will be, we'll be working in PyCharm, building much more detailed functions and having all the data just passed to us by the Python module here. Okay. Just before we move on, one last thing. There's an edit as option over here that's just to say letting you set the language that each module runs in. You can have this on name changed run H script instead of Python. Obviously this is a Python course, and also Python is much more robust and can do a lot more awesome things, so we would generally use Python, and it is the default language for all of these except for the expressions. If we go to expressions, it's by default H script expressions, but we can change it. But I just wanted to sort of point that out in case you did want to do maybe an onInputChanged but just with an H script expression or something like that. Okay. And if you're using an older version of Houdini, I can't remember which version, I think 16 backwards, I think it's the Python module or it's these events, it's one of the two, by default is set to H script, which is super bizarre. In fact, I actually think it was literally the Python module, and I thought that was quite a strange mistake, because it's literally called Python module, but by default it started in H script, and you had to go and always remember to create it and then change it, which is a bit odd. And also you can create these actual scripts using scripts. Like you can actually, the same way we were able to create parameters using Python, well, we can actually create a whole HDA and create these scripts using Python. But when you do so and you create that script, it automatically defaults to H script, and you have to go and forcibly set it to be Python. So it will not take on these defaults. You know, here when you create a new Python module, it now defaults to Python, but if you did it externally, then it doesn't trigger the same default. So it will create it as an H script, and you have to, there will be an argument where you have to tell it specifically to be a Python script, even though it is called the Python module. Okay, so just look out for that. All right, so we're going to leave it there, and then in the next lesson we're going to just play around with all the parameter callbacks and some menus, and you can get multi-parm blocks, and there's a lot of fun things we can do with Python. So I'll see you all in the next lesson.